Hello, 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 everybody. Welcome. Really excited to have you guys here and welcome you to Flatiron School's Intro to Data Analysis using Python Libraries. My name is Corey and I'm the Marketing Events Coordinator here at Flatiron School. A big part of my job is hosting free introductory events like this within the tech industry, along with panel events where we get to hear a little bit more from tech professionals in the industry. Quick reminder for tonight's event, we will be saving all of our questions until there's breaks, but you can also put them in the chat. You can use them in the Q&A function. And as there are breaks, we will get to them. If it's something that needs to be talked about right in that moment, I will direct that over to Lindsay. And then without further ado, I'd like to introduce our host for the evening, Lindsay Berlin. Go ahead, take it away, Lindsay.
Hi, welcome everyone. I'm excited to get this started. My name is Lindsay. I am an instructor for data science here at the Flatiron School. I've worked for the Flatiron School for about 2.5 years now, have a background in marketing and publications. And yeah, really excited to get this started. So I'm gonna go ahead and share my screen and we'll talk through a little bit of what this is gonna look like today. So here is, let's also put this in the chat. Here is the GitHub repository that we're going to be working with today. So this GitHub repository is a place that collects code. GitHub is a place where people put their code up online. And we've done the same thing today. If you would like to follow along and try to practice the code along with me, I might move fast at times, and so don't feel bad about if you can't catch everything up. There's a complete version with all the code here, but if you click this launch binder button, it's going to load up in, it doesn't load up in a new tab, it takes over that tab, but it will take a few minutes to load. You can see a preview of the notebook here, and once this is done loading, you'll be able to actually run your code in this the same way that I will on mine. So I'm going to move back because it didn't open in a new tab, but this launch binder button will allow you to code along in this blank code along notebook alongside of me. It won't save your progress, but it will let you practice along with us. And like Corey said, this recording will be shared out. Another thing is also we've got a complete version of this that has all the code populated as well that you can check out. So those instructions are down here in case you are curious. But with that being said, I want to go ahead and open up this notebook. So it's going to be this one right here. I have it open locally so that I can run it on my computer. Cool. Welcome. We're going to be doing data analysis using Python libraries. I'm assuming a pretty rudimentary understanding of Python. If you've never touched Python before, some of this stuff might feel a little weird. Like, what is this notebook interface? Or how exactly do we even run or write code? I'm going to talk through a little bit of that, but I am assuming a little bit of Python knowledge just so that we can actually go through and start digging into what exactly the data analysis looks like. Basic Python things like assigning variables and actually starting to use these libraries. If you don't have the Git repo, it's going to be this one right here. Let me copy and paste that into the chat again. Cool. So before we actually get into doing this stuff in code, I want to talk a little bit about what data analysis really is. Data analysis is just a process of asking and answering questions with data, right? Analyzing data so that you can answer interesting questions. And I started with this idea of questions because certainly you can go in and look at data without having a guiding question in mind. That process is usually called exploratory data analysis, or EDA, as sometimes you'll see it online. And that part is really good for exploring data that will not work. I'm seeing that I'm getting an issue. Make sure that when you click into this, this will not run, but make sure you click this launch binder button following the instructions to access the code in order to actually access the code and follow along here. So data analysis is this process of actually asking questions and starting to really get at the point where you find something useful, right? Get to something that answers that question. Exploring the data without a question, totally fine, but sometimes that process can be a little bit open-ended. And what we're going to really focus on is answering specific questions that mimic some of the things that you might be asked to do in the real world. And we're going to use a data set that is live. Basically, I have a downloaded version from yesterday. You're welcome to download today's if you would like, but we're going to go through and use a real data set that's on open source, actually based out of Austin, where Corey is, so that we can play along with it. So I like this representation of what data analysis is because it's really high level. It, keeps things pretty simple. Define your question, right? And then go through these processes to do it. But I wanted to point out these arrows currently look like they're only going one way, and that's really rarely how the process actually goes. This process can be much more cyclic as you have findings later on that have you revisit earlier parts of the process. We're going to go through this in a pretty straightforward way because we have a workshop, we've got so many minutes to go through this, but often in practice, this process goes back and forth as you continue finding new things about the data, finding new issues, finding new things you have to clean, stuff like that. So with that being said, let's go ahead and dig into our scenario and start looking at the questions that we're going to try to answer using data today. So the scenario, we're working for the Austin Animal Shelter. They have a ton of data. Our task is to process and find some initial high-level insights to figure out what's in that data. So it's a bit exploratory, but we have some guiding questions in mind. Insights like this that are just in a notebook that just sort of look at the data set themselves, not super helpful. So we're going to craft some good visualizations using an interactive visualization library so that we can actually build something that we could give to someone that's non-technical so they could see what we're finding. Cool. The data we'll be using is coming, like I said, from the Austin Animal Shelter. And if I go over here, you'll see that this is an open data portal. All right. So there are open data portals all over the world for all kinds of different purposes. And some of the most fun ways to start getting into data analysis is to find data you care about out there and just start exploring, just start answering questions you have about the world around you. So this is just one that I happen to know about and enjoy playing around with. We can see at a high level some details about it. It was updated today. I have the version saved into this folder from yesterday. But you can see a few details about it. Like, for example, there's 136 rows of data. 136 rows of data. That's definitely the kind of thing where Excel might start slowing down. That's one of the reasons that we're going to use Python and Python libraries in order to get into this. So in order to get this, I've already downloaded the data into this this folder that we're working in. But if you wanted to download a later version, you can explore some of the things up here. This API would allow you to access it directly, or you can, I think it's, export. Yeah, you can export it as a comma separated value file or CSV as an easy access way. That's a really sort of small way to export data out. So with that introduction to what data we're going to be working with, we don't know anything about what's in the data yet. Let's go ahead and get started and see what we have here. So we'll use two libraries today. One's called Pandas and one is called Plotly. Pandas is a very commonly used library for data parsing and data manipulation. And Plotly is a visualization tool that is interactive by default. So it'll be kind of fun once we get there. So first thing, before we get into the real questions about our data, we're going to just start to explore and load up this data and see what it is, right? So we need, like I said, those two imports because we're using two libraries today. So now is the time. Hopefully, if you've had a chance to, you've been able to come over here, click over this launch binder, and this hopefully has had a chance to load. Once this loads up at the top, you'll be able to run the code with me alongside of it. So it shouldn't take too long to load these days, and it should take you directly to this notebook where you can scroll down and start running the code just like I do in here. Okay, I'm going to do it in this screen, but it's the same thing. So how do we import a library in Python? right? That's the first thing we've got to do. All a library is a collection of classes and functions that have specific purposes that are written for others and available for use. Python has this great way. The reason why Python is such an exciting library to work with is because it's a huge part of the open source community and so many people contribute to it, use it like both through contributing directly to Python, but also by creating these libraries accessible to others. So we're going to use, like I said, pandas and plotly. This links directly to the documentation for those, but I'm going to go ahead and show you that all you need to do to import these is to type import and then the name of the library. Now, the fun thing about this is that when you're importing these, sometimes you have to do more than just this. If you ran this, this would work. But, oh, I can definitely slow down a little bit. Thank you for calling that out, JS. When you type import pandas, this works just fine. But there's some conventions for really commonly used libraries, and we're going to alias this one as PD. Importing pandas as PD will allow us to use PD as a little shortcut for all of the different functions that are part of this pandas library. So we're going to type import pandas for PD, and then for Plotly, we're going to use specifically Plotly Express. So I'm going to pull up this documentation. Documentation is always a great way to get started with anything in Python, especially any Python libraries. And they always have these great getting started guides for all of the major libraries, how to install them, etc. This is a little bit further than we're going to go, but one thing you can see here is you can see those conventions. So we're going to type exactly this, import plotly.express as px. And so that's going to be that convention. So instead of having to type this whole thing every time, we'll only have to type px. So here, import plotly.express as px. Now, in order to run this code, I'm going to type Shift Enter. And you can see it takes a second. And while it's loading, it has a little asterisk. And then once it's run, it's going to be a 1. That same command is going to be the same for you all. Shift Enter is going to run that code. How do I know it's worked? Well, now I'm going to try to access one of the functions in here. Okay, I'm going to try to access the data that we have using a function inside of pandas. So pandas has a function called read CSV. Okay, why do I need read CSV? Well, I'm going to hop back over to the Git repository we're in, and you see I have a data folder. If I click in that data folder, you can see I've got a file here that ends in CSV. Cool. That's what we're going to import here. Okay, we're going to pass into this a Python string object. So it's surrounded by quotes because it's going to be a string, not a number, aka anything that's not a number for the most part. And so this, I'm going to type in the location for the CSV file. That location is going to be data slash, and then I'm going to start typing this. But I don't know about you all, I'm really bad at typing without typos. Luckily, coders are all notorious for that, and you don't want to have a typo mess up lines and lines of code. So you can start typing something like this, and then hit the tab button, and it completes that. I don't type that fast, I promise. All I did was I started typing AU, the start of that file, and pushed tab to complete. Way easier than having to copy and paste or having to memorize the file name. So I'm going to PD from pandas, read this CSV file from this location. Now I'm going to run Shift Enter to run that. If tab is not working in your binder, that's going to be something where it should typically work in most instances. If you're in the binder, it should work. Normally does. I'm not sure what it's, could be a computer configuration, could just be your unlucky day. But do know that if worse comes to worse, you can always copy this file location. So what this has done is it's showing me,
It's saying
yes.
tab does not work here.
Yeah, and so because of that, yeah, I'm not sure why it wouldn't work in Binder. That usually works every other time I've tried it. It could be a computer configuration or something about the keyboard. It could also, like I said, just be your unlucky day. But luckily, you don't have to use tab complete. It's just a shortcut. Instead, you can actually go through and find this location, data / the name of this file, and you can copy and paste into this. So it will look like that. Cool. Now, one thing that's sort of interesting is I've got this, but I don't just want to read, I don't want to have to read this in every time. I want to save the output of this. And I can see that this is the output from here. This is our first look at this data. Okay, so I've read it in, I can see the data, but I want to save it to something. I'm going to save it as DF. Why? Because DF is short for data frame, which is the name of this type of output. So I'm going to take all of this output and assign it to this variable DF. Okay, so DF equals all of this code, shift enter. And now you can see that that output has disappeared because I've put it inside of this. Cool. Well, if I wanted to see what's inside of this, all I have to do is then type it on a new line and I can run this. And now you can see it's that same output that I had before, but now I can use just DF here instead of having to type all of this every time. Now, if I wanted to look only at the first 5 rows, I can use a function from pandas called .head. I don't have to call pandas every time I use pandas functions. I can do it on these pandas objects. So this object in data frame DF here is a pandas data frame. And on pandas data frame, I can put .head. And it will show me the first, it defaults to the first 5 rows. I can show many different like numbers of rows, but .head is going to let me take a peek at this. So .head allows me to see just the first 5 rows. Interesting thing about Python, if you're new to it, Python is 0 indexed. It starts at 0, it doesn't start at 1. It always trips people up when they first get started. Do not be alarmed, but it is something to keep in mind. So head allows us to look at the first 5 rows. I can also look at the shape of this using predictably df.shape. Now, I'm not going to put parentheses after. One thing that as you're getting started with Python, there's a difference between attributes of objects and methods or functions. This is a method that basically says just show these things, whereas shape is going to be an attribute of it. And you can see that it tells me that I've got 136,000 rows and 12 columns. That matches pretty closely to what I expected when I looked over here at the data set and it said, what's in this data set? 136,000 rows. So good, we have all of the data we expected. That's important. Sometimes that is not the case. You do not have to download the CSV file, by the way. It's already included in this repository. And so if you are in this repository and working on the binder, you should be able to access it the exact same way. Cool, cool. Let's go back to our code. So I can look at this shape. That's an attribute. Oh, I don't think the asterisk means anything. I think that's actually in the data. Not sure what, that would be something to ask the people who are actually entering this data. But yeah, doesn't mean anything there. df.shape, so this is the shape of our data. It's an attribute. And then if I want to look more into the things like the information on the data set or some descriptors, I'm going to use some common data frame functions. So I'm going to do df.info. This is an actual method, so not an attribute. Attributes do not need parentheses, methods do. So this method tells me a little bit about each of these columns. You can see, for example, that not all of the animals in here have names. Null means that that entry is blank. And so you can see that for most of these, I have the same amount in this column or in this specific column as I do in the whole data frame. But for this column, I'm missing some information. Not all of these animals have names as they come into the shelter. I can also see here that all of these are object types. We're going to revisit that if we have time to get to that very last question on there. So this object type just means that this is all being read as strings or as text data. And if I wanted to know something, because all of this is all string or text data, when I take this df and I call .describe, it is going to describe the data set. It's going to tell me how many entries I have in each column, how many different unique values I have, and then what is the most frequent and how frequent it is. So Max is the most common name with 619 different animals in this data set being named Max. I'm guessing they're not all the same animal, and we can hopefully use this animal ID as more of a unique identifier.
We
Although
have
I can
one
see we
more.
have some animals are coming in over and over again in here.
We have one question about Nan and Null
Yeah.
and about the GitHub repository.
Yeah, so everyone should be able to access the GitHub for this specific entry. It is public and it is accessible. So maybe we can pop that link again in the chat. And NaN is exactly how nulls are going to be represented in this data set. So let's see if we find an example. We're going back to the first 5 rows, and you can see right here, that's not a number. That is how Pandas is representing those null values. I'm not sure, well, yeah. There's a couple of different links going around, but make sure you get the github.com, the one that's intro data analysis workshop. Cool. I think for the most part, we've been answering questions as they've come up. I don't know of a Slack channel or Discord channel for this in general, but yeah. And just remember, if you're not able to follow along in live code with us, you can always revisit this later. We will have a recording that will be shared out. Any questions on some of this initial how to run methods and call attributes of Python and Python? We're starting already. We haven't used any base Python. We're only using Pandas so far. Great question, EJ, about where to save data. So if, for example, you wanted to save another data set, like using this export, it doesn't necessarily matter where you save it to, but you need to be able to tell your notebook, this notebook instance, exactly what the relationship is between where the data is and where the notebook is. So you have to give it that path. If you are using the binder instance here, you won't be able to access your own local computer, right? This is happening. This binder is launching something in the cloud and is only going to be able to access resources in that cloud instance. And so, but typically when you're working like I am on your local computer, I can access folders and files in any part of my computer as long as I give it the exact path. And Jenny asked a great question about what is Pandas exactly. It's not a library where data is stored so much as it's a Python library of useful functions and methods. Otherwise, if I wanted to, for example, read in this, I would have to define my own Python function for that. And that would be really cumbersome to do for every new thing that I want to do in Python. But someone's already written it for me. Someone's written the function that allows me to read in the data and then start accessing it in different ways. And so what importing pandas does is allows me to access the functions and Python classes that other people have written that are available in open source. That is the power of the open source community. That's why you always hear about it. It's super exciting because it allows us to access many different things that other people have written, so we don't have to write it ourselves. Cool. So I want to actually get into the data analysis of this. So I'm going to pause on questions. I will say Pandas has a great cookbook on their own website. So if you go to Pandas website, which is linked or up here, they have what's called a cookbook for getting to know Pandas as a library and starting to learn how to use it. Plenty of tutorials also on YouTube and other places. And this process of using pandas and visualization libraries to ask and answer interesting questions is the focus of the first phase of our data science curriculum. We go way past it in the later phases, but this kind of mimics exactly what we ask students to do in our data science course as we start getting used to and exploring data. So time for some data analysis. I have outlined 3 questions, and I hope we have time for them all. We'll definitely get to at least 2 of them. So, what kind of animals are brought into the shelter? What are the top 10 most common dog breeds that are brought into the center? And how has the number of animals brought in changed over time? I could see these being really common questions that someone who runs an animal shelter and has a lot of data might wonder about their own data, right? What is it telling us? Because they probably have some ideas, but they want to see if those ideas are backed up in the data that they have. So those are the 3 questions we're going to dig into today, and we'll get started. Question 1, what kind of animals are brought into the center, right? And by the center here, I mean the Austin Animal Show Center. So we have, and I'm going to just look at the whole data frame again, this df.head. We have a column here called animal type. How do I access just this column? Well, I will show you. So instead of calling .head on this, I'm going to access this by using square brackets. And you'll see when I type them, I type 1 and it puts both up. That's just a useful convention, another shortcut that coders have because they always want to make sure you have the closing bracket or closing parenthesis. So I'm going to df square bracket, and then all I need to put in here is a string for the name of the column, animal type. So I'm wrapping this to make sure it knows that this is a string. But if I put it inside of quotes, and it doesn't matter, you can use single quotes or double quotes, but I can do it just like this to access the column of data. So just that one column. Cool. How do I explore the breakdown of that column though? Well, I have this column by itself, but I want to explore more than that. I want to know what values are in it. So I'm going to use a method called value counts. So in order to use a method, I'm going to call it with a dot value underscore counts. And this is a method, like I said, so it takes parentheses. Shift enter. And you can see that what it's done is it's aggregated up here. I've got 76, almost 77,000 dogs, just over 51,000 cats, and then some other animal types, right? So here I've actually grabbed the output of this column and sort of aggregated it and counted up how many of the different values I have. Cool. Now, one thing that you might look at, livestock is only 24 out of 136. That's a really small percentage. To visualize that when I already have an other column seems a little silly. So because these are such small percentages, and by the way, I can check the percentage inside of this by passing an argument into this method called normalize equals true. Normalize, and I'm going to show you what this does. What it does is it makes this a percentage of how much of the data it actually captures. So now we can really see birds are less than 1% of the data and livestock is like real small. So definitely don't need to be visualizing that. So I can run this either way, either with normalize equals true or normalize equals false, which is the default. This is what we had before. Anytime you have a default value, you don't need to put it. But you can see that that allows us to look at it. And I can see that these are really small percentages of the data. So I'm going to lump them in with other. How do I do that? How do I start to actually make changes to this? Well, Pandas has a useful function called replace. I'm going to call on the same column. And here I'm going to use replace to replace 2 things using a Python dictionary. Okay, so a Python dictionary has a key and a value. Our key here is going to be bird, the name of what it currently is. And then I'm going to use a colon to tell it what value I want it to be. I want it to say other. I'm going to do the exact same thing, separated by a comma that says livestock will now become other. Okay, so this inside of these squiggly brackets, these are the same button as the square brackets we're using here, just with a shift. So I've got these squiggly brackets that represent that this is a Python dictionary. Dictionaries are made up of key value pairs. And here, what it's taking is the key captures what it currently is in this column, and the value captures what I want it to be. Cool. I'm going to run this. I can't really tell whether it did it or not, but I can run methods on top of other methods. So let me show you. I can run value counts on top of this method and just start stacking them, not with an asterisk, just like that. And here, basically, I'm checking my work, right? I'm no longer getting any bird or livestock. It's lumped them in with other. Cool. One thing though, I'm going to take that away, that value counts, because that was just to check my work. One thing I want to note is if I wanted to see how that changed, if I look at this down here and call dot value counts down here, you're going to see it didn't save my work. Frustrating. Pandas was just showing me here what it would be like, but I haven't actually saved it somewhere. There's a couple different ways to do that, but I personally find that it's easiest to basically save over that column so that I set df animal types equal to what it would be if you replaced it. That's not the only way to save that change, but it is a very easy way to do so. And this will basically say, take this column and rewrite it so that you have it where you've replaced these two options with other and aggregated those. So now I'm going to run this cell, and you can see I'm no longer getting an output. That output is kind of a hint that you should check your work. Anytime you get that little out underneath it, it means that it's showing you something, but maybe didn't save it anywhere. So now if I rerun this, it didn't save it either. Cool. All right, that's odd. It totally worked when what did I do this time? Fun. Okay, that's weird. That totally should work. Oh, thank you. So you know what I did? If you do df.head here, I have a new column that I just created. Now I showed you how to create a new column. Thank you for checking my work there. This is why I am usually very careful about typos. Cool. So if I wanted to, I can do types here and work it that way. So I have my original animal type and my new animal types. And that's not a bad thing. Now, if I wanted to know which ones are birds or livestock, it's preserved in the original column. Thank you for everyone who caught that. Sweet. So now I've got this. I'm going to capture this whole output of value counts as a variable. So I'm going to save this whole thing as animal counts, type count. You can name it whatever you want, but animal counts is now going to be a new variable that captures this. Okay. And I just created a new cell here. I'm going to look at what this looks like. Right now, it looks exactly like that, but I want to reset the index so that it kind of forces it to be a data frame. Right now, this is what's called a pandas series instead of a pandas data frame. So I'm going to type reset index, and we can see what that looks like. Okay, now I basically have a column for the animal type and the count of the animal type themselves. I don't have to do that. I just wanted to showcase that you can move between the two different types of pandas objects, between a pandas series that renders like this and a pandas data frame that has this index value here. So I'm going to save that animal counts like that. And cool. But index isn't really super useful here, right? Index doesn't tell me what it is, okay? And animal types isn't accurate. Animal types actually captures the count. So let me show you how to rename columns, okay? I'm going to use dot rename. The best part about Python is how accessible some of these functions are. They're named almost always in pure language, like English. It's usually fairly accessible that way. But I'm going to rename columns, and I'm going to use once again a Python or a a Python dictionary. So dictionaries call for squiggly brackets. I'm going to pass in the current name of what it currently is. So that's going to be index. And then what I want it to be. Let's rename this. This really captures the type of the animal. So I'm going to call this type, and then separate it by a comma for different entries. And I'm going to rename animal types here. Animal types as count. Okay. So animal counts, I'm renaming the columns so that index becomes type and animal types becomes count. Haven't gotten to express. We're about to. Cool. So you can see that it renamed it. Once again, I have to save that. So I'm going to copy this and paste so that I set animal counts equal to the renamed version of it. Oh, and I'm doing this in different places, but you can see that I can go through and check my work here. The computer is blipping a little bit on my screen, but here, this animal counts now has, well, here I'm checking my work really. Okay, cool. So I have type, I have count. Let's visualize it, right? So here is where we're getting to express. So great question in the chat about what is this express thing? Express is a form of this Plotly library, and I'm actually going to go to this site, okay? So let's actually put it right here. We're going to create the most controversial of plots, the pie chart. Some people love them, some people hate them, but it's really good for very few amounts of categories, especially when the categories are enough of a chunk of data to actually be rendered on the pie chart. Okay. Why did I take us to this page? Well, this is the documentation, right? When this person or this group of people, this whole Plotly team, wrote this Python library called Plotly, they made an aspect of it called Express. And inside of Plotly Express, anything where you see PX, you know that that's Plotly Express. You can see that they're able to actually, they're showing me examples of how to use it. That's what documentation really does, is that it tells you how to use something. Plotly's documentation isn't my favorite. They do it more through examples than through like sort of telling you exactly how to build it up. But you can see here that what I really need to know out of this is that I need to set a fig object, right? I already have df. I already have my data. I don't need to load up more. So I'm going to I have my df. I need to have Plotly Express build a pie chart that takes in my data where values are the counts, the numbers, and the names in our instance is going to be the types. So what I'm going to do is I'm going to just copy and paste it, and we're going to show you how to change from documentation, which is true. You'll find documentation for every library out there. We're going to copy this and bring it over. Okay. And now we're going to like walk through what that actually looks like. So I'm going to go through and type it so we can see what it used to be and how I'm going to change it. So fig equals px.py. So px is the name of the library, Plotly Express, and we're going to call a pie chart where my data is actually going to be this animal counts. That's the data I want to look at, just these three. So my data is animal counts. My values for that are under a column named count. And my names of the pieces are under a column named type. Okay. I'm not going to give it a title just yet, but I am going to do fig.show. Okay. So fig.show. And show here is a function. I'm going to take this, by the way, and I'm going to make it into a code comment. So it won't actually run. I don't need their data. I don't have this stuff. So I'm going to command question mark, or if you're on a Windows PC, it's a control question mark. All you have to do is actually add these, but it's just a shortcut to add this pound sign. These pound signs make this so that this code won't run. Okay. So here I've got my figure is a pie chart, and I'm going to show it. Ta-da! I said it was interactive, and I promise I'm right. So you can actually mouse over this. Plotly by default is an interactive chart. And so you can actually mouse over the different pieces. There's lots of websites that by default will can easily take in a Plotly object and say and render it, stuff like that. So Plotly is a fun one to use. And you can see it gives me the exact count here. I can use different parameters to change up the different things that show here. I could also change up the colors or add a title, but for now, this is a pretty good start. By the way, so in order to run these, whenever I'm in a cell, when I'm in this green version along the side, I hit type or shift enter to run the cell, or you can push this run button. Cool. So we just got to our first plot. We've been able to answer the question, how many different types of animals come into the shelter? Mostly dogs, a good amount of cats, and the rest is really other. And that other is made up of things like livestock and birds. Getting a syntax error. That would be the kind of thing where I would definitely double check that you've got commas in the right place, that you've got these string values around the names of the columns, and that you're really calling the object that was up that you named it. You might have named this something different. So check for typos like I made. By the way, Terry, you asked about Express to conserve resources. I actually think it's Express in terms of how much you have to code. Plotly itself has a lot of different ways that you can turn these knobs and buttons to like make changes to the plot, but Plotly Express is more of an express way to get directly to a plot with only a few lines of code. I just want to revisit, by the way, if you lose me at any point, we've got a recording coming out. I promise. I know that sometimes I go fast, but I want to get you through lots of different things. And I know everyone's coming into this with a different level of familiarity. So if you get lost, I just want to point out that if you go to the original GitHub repository, I have a complete version that has some version of what I'm coding. It's not obviously going to be exactly the same as what I'm coding live in front of you, but it's pretty close. I did walk through this, and you can see the code that I'm running in the complete version of the notebook. And you can actually click that directly on the GitHub and it will render it. Sometimes it takes a second, just refresh the page. Tyler, that is the benefit of using a notebook. So Tyler asked, why don't I have to use print? It is a benefit of using the notebook. If I was running this Python from the command line or something in a different way, I would probably have to use print statements to start to see and visualize. But using a notebook like Jupyter allows me to see the output of the code and the things that are actually rendering directly in the notebook, which is why it's used quite often for data analysis and data science, especially when you're just playing around. If this doesn't show anything, definitely just make sure that this is very that there's no typos, that you've got periods in the right place, commas in the right place. It could also be that if it doesn't error, but it just doesn't really load, it could be that it is taking a second. So I would try rerunning this cell. In terms of how long will you be able to access, I'm not planning to take down this workshop repository from our site, so you can access it as long as you want. If worst comes to worst, if you wanted to save it, you can always fork it. Forking it will make a copy on your own GitHub account if you have one. And then you can have access to it forever. If you wanted to export it, you would want to go into the Plotly documentation and figure out, I think it's fig.save, but I don't remember exactly. It could be save fig. I don't remember exactly for Plotly. Usually I do this where I'm rendering directly on a website. But yeah, to export it, go in the documentation. And the good thing about coding is there's always an answer. Sometimes it just takes a while to find it. So, okay, y'all. I've seen some stuff in the Q&A. How is Python used in a real project? Just like this, exploring data, real data, right? This is pretty similar to what we're doing right now. So I've got that Q&A in the chat. How is Python used in a real project? a lot like this. How are you going to know what's in this huge data set that I can't open in Excel, right? 136,000 rows, probably too much to play around with in Excel easily. And so I would use something like this to explore the data. Yeah, thanks. With that, I'm going to move on to question 2, y'all. Okay. What are the top 10 most common dog breeds brought into the center? Now, I'm asking this question, and I'm going to warn you in advance, it's going to get messy, okay? But let's get started. So let's revisit what is our data frame originally, right? We've been using this different object. I'm going to move back to df.head, okay? That's the data frame in general, okay? And you can see I've got animal types and breed, but I don't want to look at cat breeds, the domestic short hairs, right? I only want to look at what the most common dog breeds are. So how do I segment to only dogs? Time for a locate statement. So I can run df.loc, short for locate. And locate, instead of calling for parentheses, it calls for square brackets. And I read these square brackets as like where. So df.locate, where df animal type. So this is the name of the column here. This is the location. Locate where animal type is equal to dog. So what exactly did I just do? I've got this data frame, and I want to locate on that data frame where this column, data frame animal type, is equal to dog. And that's the thing we want to find in here. This is a conditional. This is a question we're asking of our data, right? df animal type equals dog. I can grab this, open a new cell up above, and you can see that I'm getting all this true false statements. Not super useful. This is basically saying, okay, the 0 row is a dog, the 1 row is a dog, the 2 row is a dog, the 3 row is not a dog. Fine, but that's a conditional. It's just a true false question. And here you can see we've got this conditional, and I'm passing that into my locate statement. So now, right now, row 3 here, our 4th row in the data set is a cat. If I run this, you can see that now it's skipping that row. I'm only locating the places where animal type is dog. Cool. So that is our segment data, and I'm going to call that df dogs. So I'm going to save this to a variable called df dogs. Okay, sweet. So now let's go back and call it here so we can see check our work, what I call sanity checks. And we can see, right, all of these are dogs. Earlier on, we did a .describe to see how many uniques were in something. There's only one unique value. These are all dogs. Okay, so df dogs, look at the first 5 rows here. Cool. And now I can start to dig into this breed, and I know I'm only going to find breeds of dogs because I'm only looking at dogs. So let's go to the columns value counts, just like we did before. Breed, make sure I spell it correctly. Always a question. Cool. Oh, well, that's messy. What are you already seeing right off the bat? I've got pit bull mix is the most common, but the 5th most common is just a pit bull by itself. And I see already that I've got some things that are pit bull here. Lots of different ways to call a dog that's maybe part pit bull a pit bull. So if I want to know what the most common dog is, I'm going to run into some issues. Okay. So for example, I'm going to use a different .loc statement here, and I'm going to find out all of the times where pit bull is in this dog breed. Now, bear with me. It's going to be a kind of convoluted conditional, but I'm just going to show you. I'm going to look at df dogs, and I'm going to locate where the df dogs breed contains the word pit bull. And in order to do that, I have to access the text in here. I can access the text in this column by doing .str. That allows me to access the text of this column and see where that text contains the word pit bull. Okay, I'm gonna run that. And now we can see I've now segmented to only the dogs that have pit bull in it. I've got pit bull mix. I've got a pit bull Australian cattle dog, lots of different options. And let's run value counts on this. I'm going to copy this into the next cell and run value counts here. Oh, that is messy. That's because it's not the best way to do that. I'm going to call this on breed because this is a full data frame. There we go. So I'm calling this column breed value counts. It's okay if this code feels a little bit unfamiliar. Let's also just look at the unique. Wow. I'm really just doing this code to make a point, right? There's lots of options. There's a ton of pit bulls, okay? And none of these seem wrong. This all seems like correct data. There's probably all of these combinations. This is something where we're starting to get at that data cleaning part. Also, yes, Eileen, everything is very case sensitive. But data cleaning, right? How do I count which dogs are pit bulls, right? Are they all of the ones that have pit bull in them? But what if they're only like a small amount pit bull, right? I don't know anything about these dogs except what's represented in this table. Behold the pitfalls of data cleaning. There's never one right way to do it. All you can do is basically make choices based on the data you have, based on your understanding of the data, based on who you're working with. And hold please. Okay, I'm back on. my headphones just turned off. So this gets at something, and I'm going to show you. Welcome to data cleaning. Data wrangling is what I'd call this. And here is an example of a chief decision scientist at Google, and you can see all the different ways someone misspelled Philadelphia. This is a common problem. It never goes away. So definitely could do something like this where I search for all the places. I wanted to just show you that this is a problem. This is something that happens. I'm not going to deal with any of it right now. And then I'll show one quick way to fix it. And then we'll wrap up probably for the session because I think that we're running a little close on time and I want to be respectful of that. So first off, I'm just going to save the top 10 dog breeds without cleaning it. So no changes. So how did I do that? Before I had that df dogs variable, and I can look at the breed, and I can find the top 10 of them by doing value counts. And now I can just look at the top 10. I can do this in one of two ways. I can do a head here, and that gives us by default the first 5, but I can also pass in 10. So here I am stacking my methods. I've got dot head on a dot value counts. I could also use Python slicing, where I use a square bracket. So where we're up to the first 10 rows. And you'll see it's the exact same. I'm going to save that as a variable called top 10. I'm going to call this version 1 because I'm going to do it in a different way in just a second. And so now I've got this top 10 v1 is this. And let's use a bar chart to represent how this is happening. So I have this documentation for Plotly once again. We're going to dive in here. Cool. You can see, again, I already have data. I don't need to worry about this one. And I've already imported it into my notebook. But this is what we're going to use. Okay. We're going to go through this process exactly like we did last time. So I'm going to set fig equal to px.bar. Our data here is this top 10 v1. An underscore. My X is going to be the thing along the bottom. We'll have that be the index of this, right? I didn't make this into a data frame. That's okay. I can set this actually equal to, oh, let me do this a slightly different way. I can either go through and make it an index using or a data frame using reset index like I did before, or I can kind of fuss with it. I'm going to actually take this out and I'm going to put that here. Top 10 v1 dot index. This index is an attribute that captures these ones. Cool. And then y is the values themselves. Top 10 v1 just by itself. Underneath that, I am going to need a fig.show. I'm going to hash these out so that it doesn't run this code that I was using as a reference. And now if I run this, I can see that I've got my top 10 here. This is the index of this, right? This index object. This index just means that it's this side part here. And then the values are captured in the object itself. Cool. Just as interactive as our last plot, but we can see that I've got Pitbull coming up kind of twice. Now, if I want to do some brief data cleaning, just the minimum I can do, one thing I could think of is what if I just take out all of the times where it shows up as mix, right? I don't have another dog that it's potentially mixed with. So maybe that would be an easy way to say all Labrador Retriever mix that's primarily a Labrador Retriever. And so I'm going to count that as a Labrador Retriever. So I'm going to actually save over and make a column so that I can capture just the times when, like, if this says Labrador Retriever mix, I'm going to take out that mix. Okay, cool. So in order to do that, I'm going to use a string method like we did before. So df dogs bracket breed, not like that, breed dot str. That string method allows me to access these things as words. And that then I can call a replace on it that allows me to replace space mix, right? Because I need to care about that space. Python's super sensitive about stuff like that. And if I leave a space, it's going to be different than if it doesn't have the space. And I'm going to replace that with nothing. Cool. I don't see any examples here, right? I could go on and double check, but I'm pretty confident that this works. I'm going to actually save this as a new variable. I'm going to call this no mixed dogs. Cool. And I can see, oops, that's not what I wanted to do. No mix dogs is this object. I'm going to access the top 10 the same way I did before. No mix dogs dot value counts. And we'll get the top 10 using slicing. So :10 will grab the top 10, right? And now I can see that already I'm getting slightly different results. So I'll call this top 10 V2 and visualization run 2. I'm going to scroll up and just copy and paste this code from up here because we've already worked through how to do it. And so now instead of version 1, I'm going to call this version 2. And we can see how that changed, right? All of a sudden, Pitbull is still number 1, Labrador Retriever. It hasn't changed a lot about the order of these first couple, but I'm starting to see more breeds down here. So I think it's slightly cleaner than what we had before. Now, y'all, I do want to take some questions on this. I did not get to question 3 about playing around with datetime objects. If you want to look through that code, it is on GitHub. It will stay on GitHub. I'm not going to move it anywhere. And so you can definitely play around with that at any time at your leisure. And if you're ever worried about it going away, you can always save it to your own GitHub account using a fork. Questions on this data set or any of the things that we did in terms of rendering these? Now, one thing to think about, if you're having trouble getting things to render on something and you're using this binder, it could be that the binder isn't working well on your computer. And you might think about maybe it's time, if you're really excited about this, to jump into like actually downloading Anaconda, which is a environment manager that allows me to run this thing locally. It's something that we do. That's how we run our code when we go through and work with students. There's lots of tutorials out there. It's not something that's in the scope for me really talking about today, but I did talk a little bit about it and did link to Anaconda. Anaconda by default, if you download it, would also download Jupyter Notebook. And using Anaconda, you can use this environment file in this repository to actually access the libraries that you would need to run this. I'm not seeing any other questions in the chat. I really want to thank everyone for coming. And yeah, Corey, I'll go ahead and stop sharing my screen.